So welcome everybody to the October edition of CEPR Political Economy webinar. My name is Sergey Guriev, and I'm one of the co-organizers of the webinar. I will chair it today. As you know, this webinar is jointly organized by Political Economy Group, by Populism Network, and by Conflict Network. And today we have a very special speaker who works with people in Political Economy Group, but will actually talk on populism. This is a paper which is going to be presented by Gilat Levy, who is a professor of economics at LSE, co-authored with Alwyn and Ronny Razin, who is also here, actually sitting next to Gilat, and we'll try to answer questions during the talk, but we'll also set aside time in the end of the talk, the last 15 minutes. So please do put your questions in chat, and also I will monitor the chat, and at some points, if I see clarification questions, I'll ask Gilat to pause and answer the questions which are better answered during the talk. With that, let me hand over to Gilat. Gilat, the floor is yours. Your paper's title is Misspecified Politics and Recurrence of Populism. Please go ahead.
Wonderful. Thank you very much for inviting me to present in this seminar. Thank you everyone for joining. Let me share the slides. So I'm assuming you all see the slides now. Yeah, perfect.
Yes.
Okay, so the paper is joined with Ronny, Razin, and Alwyn, both at LSE. And so here is our motivation. We are thinking about how to model political conflict, and the standard type of political economy papers that we analyze usually assume that groups in society differ either in their preferences, so that is one dimension of a political conflict, or even if they have the same preferences, they may have different information, and that is another source of conflict. And what we do in this paper is focus on an additional difference. You may have the same preferences and the same type of information, but you will interpret the information differently in the sense that you may have a different model of the world, okay? A different way to see the world and update your belief given the information that you observe and so on. And coming from theory, it is quite standard for us to think that it is impossible to learn anything without having a model, okay? And it would be the case that fully rational actors often have persistent differences of opinions that may relate to the fact that they start or have different models of the world. So, you know, our colleagues in macroeconomics have big conflicts over what is the correct model of the world. And of course, in physics, there have been well-documented conflicts about this. So this is our starting point to think about how this is shaping political conflict. And in the political sphere, when you think about differences between models or views of the world, these are going to, of course, translate into different outcomes. So a different politician that has a different model of the world is going to implement different types of actions. And the key issue here is that it's going to affect the future learning of everyone in society. And that can create long-term differences between individuals. So this is the type of environment that we are focusing on. So we're considering political competition between groups that share the same interests, have the same preferences of a common outcome, observe the same information, but differ in their worldview. And specifically, we're focusing on a particular environment. We're looking at the conflict between those with a complex worldview, which I will define, and a simple worldview. Okay, so it's a simple environment in which we are sort of confronting complexity versus simplicity, and we want to see which view is winning. And this is where I come to the populism in the title. So here are some couple of nice quotes. So Dahrendorf, which was a director at LSE and a sociologist, said, "Democracy is complex, populism is simple." Okay. And another quote from the American writer Mencken. So there is actually it's not clear if he actually said it, but it's attributed to him. "For every complex problem, there is an answer that is clear, simple, and wrong." Okay, so even if he didn't say it, it's a really cute quote and should be said. So we the feature that we attribute to populism is the fact that it can be viewed as a simple view of the world. For example, a lot of populists in many types of societies focus on a small set of variables as affecting policies or as solving everything if you want. So if we build a wall, we solve everything. If we, in the UK, leave the EU, we solve everything. Now, it's not everything about populism, and this is a contentious field, and what exactly is populism, it is not very clear. But the idea that populism constitutes a simple view of the world sits well and fits well with other views of definition of populism. So one very successful view is that the populists are those that are anti-elite, and they represent the will of the populace, the will of the ordinary people. So if you try to cater to a common ground, you are going to have to advance quite a simple view. For example, it will have to be anti-pluralistic view. There is no room for subtleties when you present the view of the people. Another view of populism is that, or political compromise is that it confronts expert-led decision-making by a polarizing opinion. Again, expert-led is quite complicated, whereas polarizing populists have to be different from experts and hence must be simple. The authoritarian view of populism against anti-rule of law is similarly, the rule of law is quite a complicated set of institutions. And so in order to advance something which is anti-rule of law, you're going to have something which is simple. So again, of course, this does not capture everything about populism, but it captures a recurring feature of populism across most types of explanation and ideas of political scientists of populist societies. So the key question that we want to answer, will political competition diminish such simplistic worldviews? More generally, the general question, will the correct worldview manage to diminish the incorrect one? Okay. In the presentation, I will assume that the correct worldview is complex and that the simple worldview is the wrong view of the world. In the papers, in some extensions, we conduct a more general analysis, and we can talk about this more generally within the framework of our model. But I'm going to focus on the fact that the world is complex. There is a group in society that understands the complexity of the world and has the correct complex worldview. And there is a group in society which has a simple worldview, and we are trying to see whether political competition would weed out those simple worldviews. And here is the key result. The simple worldview is not diminished. In particular, we're going to have perpetual cycles of changes in power, and so that the populists or those with a simple worldview are going to be in power for a substantial share of the time. So those with a complex worldview and those with a simple worldview are essentially going to share power. That is the long-term steady state of our economy. The simple worldview is not diminished. In our model, the complex group is going to converge to have the true beliefs about what actually create what is the state of the world. The simple group that start with the wrong model are going to converge to have wrong beliefs about how different inputs affect the output. Specifically, they're going to have exaggerated beliefs about different policy variables and how they affect outcomes. So they're going to implement wrong policies when they're in power. A feature of these wrong policies is extremism. So in our model, simplicity implies extremism. So the beliefs and policies of the simple group are collinear with those of the complex. It means that each of the policies that they both share in the sense that they both think are relevant, each of these policies, the beliefs of the simple on these policies are going to be more extreme and in the same way compared to the beliefs of the simple, which are the true beliefs in our model. Okay? A theoretical contribution of the paper is to show convergence of beliefs in a dynamic model with individuals that have misspecified models. This is a relatively complicated environment in the sense that we are learning, the individuals in society are learning about the value of the parameters in a situation in which the data is endogenous. So they get non-IID data, and we have a multi-dimensional state space. So it's a bit complicated, but we find a way to show convergence. Let me give you the intuition for the key results of why the simple will always get to power at some point. So we cannot have those with the correct worldview in power all the time. So insofar as the simpler view is misspecified, periods in which a more complex policy is implemented is going to increase the omitted variable bias of those with the simple model, okay? So they focus only on a small number of policy variables that they think that are relevant, and hence they will have an omitted variable bias on the parameters that affect the outcome. So this increases their assessment of the effectiveness of a decisive, narrow policy that includes only these policy variables. It will increase their intensity to win the election, and hence they will mobilize in greater number and get to power, okay? So they systematically underestimate the outcomes of complex policy and overestimate the positive benefit of their own plan, leading to exaggerated policy, okay? So whenever they're not in power, the omitted variable bias increases, and hence they become, as I will show you, they become more intense in their will to win the election because they want to implement even more exaggerated policy. So our framework provides a motivation for the recurrence of extreme, misguided, and harmful populist policies, as, for example, Dornbush and Edwards documented in their famous paper. Okay, let me quickly mention the literature that we relate to. There is, unsurprisingly, a growing literature on populism. So, for example, the paper of Gizzo and al. Focuses on the fact that economic variables are quite important compared to cultural variables, or we shouldn't underestimate the importance of economic variables compared to the view of Engelhardt and Norris. And they also use a model in which turnout is important, and that is a key feature of their model, and we use a model of turnout as well. Acemoglu, Egorov, and Sonin look at the idea of populism as resulting from pandering. Morelli, Nicolo, and Roberto also look at the sort of type of simplicity versus complexity of politician, whereas complexity is modeled as a more contractual type of policy and hence more uncertain. And if you want to read more, a fantastic survey by Sergei and Elias Papaionou in 2020 gives a very good synthesis of the literature on populism. Our paper relates to a recent literature and theory on misspecified models. The main assumption in misspecified model is that your prior distribution over the parameters puts zero probability on the true parameters, okay? So there is something that you will never learn, okay? So your model is misspecified. In our case, those that have a simple worldview are never going to consider some policy variables that truly are relevant, but they will simply never consider them, okay? So this is this type of literature that is quite concerned about what could be the type of learnings that we will have in the long term and whether we converge to have, what types of beliefs do we converge to and whether we converge to. Specifically within this literature, there are a couple of papers that relate to what we do in the sense that they also model competition across misspecified model. So Elias and Spiegler look at static political competition between politicians that use Bayesian networks as their causal models. And Montiel, Olia, Ortoleva, Pai, and Pratt look at competition between models in an auction framework. The key difference is that they look at how models compete to explain exogenous data. In our model, the data will be generated endogenously. So whenever a politician comes to power, they implement a particular policy, and then everyone learns from the outcome of this policy. So learning is given endogenous data that is created in equilibrium. Okay, so unless Sergei, you want me to answer question, I'll go to the model, which is...
There are some questions, but Ronny has answered them.
Fantastic. Okay.
So, yeah. So the general question is, are all populists bad, ineffective, and incapable? But I guess you've already said that you clearly define the capacity, competence of populists, and so it will be part of the model.
Yeah, good. So as I said, in our model, the simple group is going to have the wrong model of the world. That is for the sake of this presentation, and we identify populism with simplicity, okay? There could be environment in which the simple world group is the correct one, and we can speak about these environments as well. So in the more general framework, you can decide whatever you want on who's right and who's wrong, okay? But I will focus on an environment in which the world is complex and the populist group has a simple and wrong worldview, okay? Okay, let me start with a slide of an overview of the model to sort of have everyone on the same page. So we're going to have two equally sized groups, okay? Equally sized just to make things simple. It's not important. In every group, there is going to be a continuum of voters, and they're all going to be the same in the following sense. Both groups are going to have the same utility from some output YT, which is simply linear, okay? So your utility is going to be at period T, simply the utility that you get the level of the output itself, YT. The true process that generates output is a linear process, okay? So we have a vector of policies, xt, and here are the parameters beta star, the true parameters, the true state of the world, if you want. So beta star prime, xt, is the way that policies affect the output, and there is a level of noise, epsilon t, which is going to be IID, normally distributed with mean 0, okay? So average output is going to be beta prime x, depending on the x that you implement at time t. Groups are going to differ, so the groups are also going to have a linear model, okay? And they're going to differ in the number of policies they believe to be relevant, okay? So I'll explain this in the next slide. The way that groups change power is according to whoever has higher intensity to win, okay? If the complex group has higher intensity to win the election, they will win, and the opposite if the simple group has the higher intensity to win, okay? So these two features are the important ones for me to explain after this overview slide. Once you win, your representative politician is going to choose the ideal policies, okay? There's going to be a resource constraint that would make sure that we just don't, you know, increase the absolute value of x here to infinity. So there is going to be a resource constraint. So you choose the optimal policy given your beliefs about beta, okay? So at period t, you're going to have the linear model, you're going to learn about these parameters beta. Given your beliefs about beta, you're going to choose your optimal policy xt. Then everyone is going to observe the outcome yt. Everyone is going to learn via the prism of their model. So they're going to use simply OLS and so on. So that's going to be a dynamic process in which each period, someone implements a policy. Everyone learns from the outcome of the policy about the value of the parameters beta, and they change power according to whoever wants to win more the election, okay? So let me first explain what are the different worldviews. So the complex group C is going to have the correctly specified model. So there are going to be n parameters affecting y, and the complex group is going to consider all these parameters. They don't know the exact value of beta, but their initial prior is going to put positive full support on all the possible, on all these parameters being possibly different from 0, okay? Group S has a misspecified model in the sense that there are some policy variables that they are going to ignore. So they think that beta k plus 1 to beta n equals 0, and they're simply not going to consider these policy variables, and they're never going to change their mind, okay? We can speak at the end about, is it possible for individuals to change the model that they are married to? Maybe yes, maybe no. For the purpose of the analysis, we're going to assume that S has a misspecified model and it sticks to this model. And what we analyze is what type of learning happens when you have a misspecified model, okay? In the paper, we have a little bit more general formulation. Maybe both groups can also put additional weight on policies that are actually completely irrelevant, okay? That is not too interesting extension. Okay, so everyone is going to learn about the values of this beta throughout the political process. So what is the economic environment and how do you choose the optimal policy given your beliefs? So as I said, utility is simply linear in the output, and there is going to be a simple quadratic budget constraint. So policy variable xi at period t, you sum over the quadratic value of all the policies that you implement, and these have to be smaller than some budget constraint r, okay? What does this mean? That the linear formulation of the output means that only the mean of your beliefs matter, okay? So the mean of each parameter beta. Given your mean belief vector beta, ideal policies are set to maximize this Lagrangian, so the output plus the Lagrange multiplier and then the budget constraint, okay? That gives us a simple solution. So the optimal policies X are on dimension I are of course related to beta I, okay? So this is in vector form. So X equals beta over 2 lambda. The Lagrange multiplier lambda, and this is an important point, as you can see, is a function of essentially the magnitude of your beliefs, okay? So this quadratic form implies, you know, it doesn't matter if you think one policy variable affects negatively and one positively. Beta prime beta is essentially a way to capture how strong your beliefs are, okay? How strong you believe in the effectiveness of the policies that you're going to implement, okay? So the higher is beta prime beta, the higher is the absolute value of the x's that you want to implement, and that means that you're more constrained, right? So that is because of R, that means that you're more constrained, and that is the intuition for this Lagrange multiplier. Okay, so putting these two together, x of beta is essentially beta over the root of beta prime beta. So for a policy variable with a higher value of a parameter beta, I'm going to implement a higher value of x. That means that beta prime x looks like this. So it's beta prime and this is x, and essentially your beta prime x is again a function of the magnitude of your beliefs, okay? So just remember this and lambda, it's a simple model that delivers to us the feature that you're more constrained when your policy parameters are of higher magnitude, okay? The quadratic form of the policy parameters. And what you think you're going to get as your average outcome, again, depends on this quadratic magnitude of your policy parameters. Okay. Okay, so now I'm getting to the question about political competition. How do we model political competition? If you want, we can make the following assumption. The group with the higher intensity to win wins. I'll give you in the next slide a model to microfound this. But if you don't want to, you know, remember all these details, just remember this. If I care more about winning rather than losing, then I will win. So what is intensity to win? If I'm the simple group, so the intensity of the simple group is what they can get when they're in power, which is the output, the average output that they will get given the optimal policies that they have and evaluated according to their model. So according to their parameters, mean belief beta S, minus what they get when they're not in power. So again, they evaluate it through their lens of their own model, but of course they have to plug in the policies of the complex group, okay? So the difference between these two is the intensity of the simple group to win. And similarly for the complex group, what they can produce minus what the other group will produce evaluated at their belief is their own intensity, okay? Here is how we think about this. If we want to microfound it in some way, you can think about the citizen candidate model in which we have one representative from each group. Upon winning, the candidate selects her group's ideal policy. Each voter is going to have a cost of voting, okay? And then you vote if you think that you affect the result with probability P, and then that is the intensity is the benefit of affecting the result, okay? According to this, if C is distributed equally across the two groups, and they both have the same belief about the probability of being pivotal, this is not a strategic belief, just some sort of belief that they have, then the intensity is what plays a role. So if the groups are not equally sized, then we need a different wedge in the intensity. But if they're equally sized, then intensity of preferences give us a tool to think about how power changes hands in this economy, okay? So I just want to spend one slide on what intensity of preferences is, okay? Think about, again, the output that you get from your ideal constrained ideal policy X evaluated with your mean belief beta. What happens if you move to X plus delta? You move away from your constrained ideal, okay? You simply get a difference in the average output of minus delta prime beta. Now we can plug the fact that both X and X plus delta satisfy the resource constraint, and we get an expression for this. And the expression depends on beta prime beta, okay? So moving away from your constraint optimum cost you, if you want, something which is proportional to beta prime beta, which is the way to measure how much you're constrained, okay? And where is this coming from? If you're not very constrained, right, what you are actually producing is your optimal policy, your unconstrained optimal policy. Moving away from this doesn't change much your utility, right? But if you are very constrained, you're very far away from your unconstrained optimal policy, then moving away from this really looms large, okay? And this is why how you view the constraint and your the magnitude of how effective are the policy variables that you're looking at is essentially the way to measure intensity of preferences, okay? So this is how the beliefs that you have that result from your model are going to tell us how we change power. This is how we tie everything together. Your beliefs, essentially, the more you think your policy parameters are effective, this would imply that you're going to gain power, okay? Okay, so one last slide of the model, the dynamics. So at period T, the winning candidate implements her ideal policy. Either it's the simple group, so they use the mean belief from period T minus 1, and they implement X of beta S at period T minus 1, or the complex group. Following the observed YT, everyone learns about beta using OLS, okay? In the beginning, you need some initial data in order to kickstart the process. If at period T, after we observe the outcome, the updated beliefs, the magnitude of the beliefs of S is larger than that of C, S is the winning candidate at period T plus 1, otherwise C is the winning candidate, okay? So we have a non-IID process because what I learned depends on the action I've taken in the previous period, okay? Or the actions that was taken by the other group in the previous period, but the fact that they were in power is because my beliefs were low enough, okay? So this is a non-IID process with endogenous action and beliefs, and it's quite complicated, but I'm going to first focus on steady state, and if there is time, talk a little bit about convergence, okay? I'm happy to take a couple of minutes for questions if there are. If not, I'm going to go to a simpler formulation.
So Ronny has answered all these questions. I have a short technical question. So you have quadratic costs which need to add up to R. In principle, you can just have quadratic costs, right? And have no resource constraint. It would be exactly the same result, right? It would still be beta squared or something. Okay. Beta prime beta. Okay.
Okay, so here is a simple model to just help us get the key intuitions, okay? There is actually a result in the paper that, so the simple model has just one policy variable for the simple group, okay? So they only consider X1. That gives us the results about cycles and some comparative statics, but it doesn't give us everything. For example, the fact that the policies and beliefs of the simple group are going to be extreme in the same way, so collinear on all dimensions that they consider. This we could get only in a multidimensional analysis, but I'll get to that. Okay, so S considers only one policy variable. So we're interested in the beliefs of S about beta 1. And let's, again, to simplify, assume that the complex group knows the truth about beta, okay? So let's assume that the true process has X1 and X2, and they know beta 1 star and beta 2 star. And let's also fix R at 1, okay? So C knows the truth, it's X1 and X2 that are relevant, and S considers X1 and has to learn about X1. So let's first go through the idea of why do we get cycles. To think about cycles, let's think about one of the contradictions. Assume that actually S is always in power. So the simple group is always in power. When the simple group is always in power, actually both groups have the correct model because the simple group only implements X1. So they have the correct model. The complex group knows that only X1 is implemented. So they both in the long term must learn beta 1 star. C knows it and S is going to learn it, okay? You're implementing X1, you have the correct model, your beliefs are a martingale, you're going to converge to the truth, okay, with one dimension. But then we have a sort of an omitted policy effect, right? Both know that X1 is affecting the output in the same way, but group C also knows that X2 is relevant. So group C is going to have higher intensity. So this is the good side of the result if you want. The intensity of group C is going to be higher. They have a better type of policy to implement. They know they can increase their utility. So it cannot be that group S is in power indefinitely, okay? So now the second side of the argument, suppose that group C is in power all the time, okay? Group C is in power all the time. If you remember your econometrics, and I'm sure some of you do, the beliefs of S must satisfy the following equation. This is the omitted variable bias, okay? So it's beta 1 star plus beta 2 star multiplied by the ratio of the two policies, which is essentially because of how we've modeled the quadratic cost, but more generally, it's going to be related to the ratio of these parameters, okay? Another way to look at it, in the long term, S must correctly conjecture the average of what it observes, okay? The beliefs of S, I can't be all the time surprised, okay? So I will converge to think that the effect of the X1, which is through beta 1S, so my belief about beta 1S has to satisfy that the true average output, which is this one here, okay, what C is producing, I can guess it, okay? So my belief is such that I can understand the true average output. If I don't understand it, and this is not equal, then I will continue updating until I'm not surprised anymore. So I have more and more data, and I can in the limit understand how C is producing this output. I only considered X1C, so it must be that beta 1S is inflated, okay? So when C is in power, S correctly conjectures the average of what they produce, right? But then I'm going to show you that the intensity of S is higher, okay? Which will again lead to a contradiction. So we started from the condition that, and this comes from the fact that S is rationally updating beliefs. They have the wrong model, but they are rationally updating that using OLS, okay? So we started from this, and this, remember, is what C is producing. So the average output that C is producing, which relates to their intensity of preferences, right? Beta star prime beta star. This is how S views what C is producing, but S knows that it can do better. Given this beta 1S, it can actually replace X1C with what it wants to do, right? Which is X1S. In this simple model, they just use all the resources. So X1S equals 1 or R, okay? But generally speaking, they understand what S is doing, and they can do better if they move to their own ideal policies, okay? Again, the average output that they will produce relates to their, is essentially their intensity of preferences, the root of their intensity of preferences, okay? So it's the combination of the fact that you, in the limit, you correctly conjecture what's going on, so the rationality, okay? Then you get an omitted variable bias, which implies that you actually want a different type of policy if you would be the one to implement. And this type of policies that you want to implement reflect your intensity of preferences. So the intensity of S becomes higher than that of C, okay? That is a general result. So if one group is in power, general in what sense? You don't have to think about simple and complex only. You can think about any two groups which have overlapping policy dimensions, okay? So one group can think about 1, 2, 3, the other about 3, 4, 5 policy variables, okay? Imagine that group J is in power permanently, okay? It must be that group J correctly conjectured the averages of what it produces. And similarly, group I will have parameters so that it correctly conjectured the averages of what group J is producing, okay? But then group I here knows that it can do better. Given beta I, okay, given beta I, it can actually implement xi rather than xj, okay? So they think they become more intense when they're not in power. They think they can do better. And what do we mean by do better? Implement the output that they like, which is related to their intensity of preferences. So this is a general feature for a more general formulation of the types of models that we can consider, okay? Let's just look a little bit about the dynamics, which also help us to think about convergence of beliefs. So beta 1 star, we're only looking at the beliefs of S now. Beta 1 star is the true parameter. So if S is in power by itself, this is the belief that it will have. And we know that these are the beliefs that give them lower intensity to C compared to C. And if C is in power, these would be the beliefs of S. And we know that in this case, S will have higher intensity than those of C, okay? So the beliefs of S that equalize intensity is somewhere in the middle between those two, between the true belief and those with omitted variable bias, okay? So what happens when S has beliefs that are higher than those that equalize intensity? It means that they are in power. It then means that their beliefs moves towards the true beta 1, so their beliefs decrease. They moderate when they're in power towards the equal intensity beliefs. Once they cross this line in this region, they have lower beliefs than those that equalize intensity. It means that C is in power, which means that their omitted variable increases and hence their belief increase. So you can see how we actually converge to this value that equalizes intensity, and how, interestingly, when populists or those with a simple model are in power, they moderate their belief, okay? So maybe it's a wishful thinking. They moderate their beliefs, and once they're out of power, they become more intense, okay? And so I said this. How do we solve for that equilibrium? The fact that we must have cycles means that we must have equal intensity in the long term, okay? The equal intensity gives us this condition about the beliefs of S. It has to, right? The quadratic form of the beliefs of S must equal beta star prime beta star. But also this must be arising from the limit OLS beliefs. The limit OLS beliefs would include the omitted variable bias, which would include the policies that S implements when they're in power. So assume they're in power a share gamma of the time. A share gamma of the time, they implement x1 equals 1 and x2 equals 0, okay? A share 1 minus gamma, they observe the optimal policy of C. So there is systemic correlation, two types of policy that they observe, either 1, 0, or the optimal x1c, x2c, okay? So the omitted variable bias takes this into consideration, but I already know what their beliefs have to be. They have to satisfy equal intensity. This means that I can solve how often they can be in power. Okay, from these two conditions about their limit beliefs, I know what is the level of gamma, which is the share of time that the simple group have to be in power. Okay, what can I say about this gamma? What I can say about this gamma is the following. If the parameters, the policy variables that S don't consider are really important. So imagine that X2 is very important, okay? If X2 is very important, it means that, oops, there should be a 2 here, I'm sorry, okay? If beta 2 is very high, the true beta 2 is high, it means that there's going to be, we need equal intensity, right? It means that we're going to have to need a huge omitted variable bias to equalize intensity, right? If beta 2 is high, we need beta 1 S to be high, but beta 1 star is small relative to beta 2 star, so we need to have a large omitted variable bias. How do I get it? I get it when C is in power more often, okay? So the share of time that S and C are in power is such that it creates just the right omitted variable bias to equalize intensity. Okay, so again, a little piece of good news is that the more important are the variable that S ignores, the more exaggerated the beliefs have to be, the less they can be in power, because for exaggerated beliefs, we need C to be in power to create the omitted variable bias. Okay, so if they're really wrong, they're not going to be in power that often. Once they're in power, they really do bad, you know, they implement bad policies, but they're not going to be in power that often. Okay, so I said that in the general model, there is an additional result that we get beyond the cycles, which is the fact that simplicity implies extremism. So of course, when you implement less policies, because of the resource constraint, some of these policies you're going to exaggerate compared to those of C. That's obvious. What we get is that on all the policies that you implement, you become more extreme in the same way, okay? So the beliefs of S and its policies are collinear with that of C, okay? And let me try and explain where this is coming from, okay? So collinear beliefs implies that for any dimension that we both consider, the belief of S is simply a multiplier of the belief of C, and this is a multiplier A, which is greater than 1, okay? So it's a nice feature that S, so the simple group actually understands the relative value between beta I and beta J correctly, okay? So it's the true relative importance of policy Xi compared to policy J, okay? But they're going to completely exaggerate the importance of each of these parameters, okay? And where is this coming from? It's the same type of argument that gave us the cycles, a little bit more nuanced. If there is no collinearity, there is sufficient variation in the data, right? What does collinearity mean? Collinearity means that, you know, all the policies are multiplied by some A and then I don't have variation, okay? If there is no collinearity, there is sufficient variation in the data. If there is enough variation in the data, what S could do when they update their beliefs and when they learn is essentially correctly guess the average output that they produce and the average output that C produces, because these policies would truly be different, okay? So they could learn sufficiently if you want, and by learning sufficiently, I mean that they can understand their average output and group C's average output, okay? But once, as I showed you before, if they correctly conjecture the average output that group C is producing, okay? Because group C does this as well, okay, as they have the correct model, then as before, we're going to get the same contradiction because we're going to find out that the intensity of group S is higher. What group C is producing is proportional to their intensity of preferences. If group S can conjecture it, they can understand how to produce what group C is doing, but given their beliefs, they think they can do more, okay? That means that their intensity is higher. We have a contradiction to equal intensity, okay? If we have collinearity, it means that there is not enough variation in the data, and hence the OLS type of beliefs of S is essentially going to average the observations under the two regimes, okay? They're not going to separate the regimes, if you want. They're not going to understand what they're doing and what C is doing. It's just going to be one big mishmash for them, and their beliefs are going to minimize the weighted average of mistakes across the two regimes, not per regime, okay? So they don't learn too much. If they learn too much, we can't sustain an equilibrium, okay? So in equilibrium, they can't learn too much. Okay, here is, if we want to look at a more general model, here is how an equilibrium is determined. So let's say group S thinks about two policy variables, X1 and X2. So I'm thinking, again, suppose that C knows the truth. So these are the beliefs of group S now. It's beta 1 here, beta 2 here, okay? And this is the beliefs that create equal intensity. So it's beta prime beta for the simple here equals the true beta star prime beta star. Imagine there are three policy variables, okay? So now instead of a equal intensity belief in the unidimensional, I have an equal intensity curve, which is essentially a circle, beta prime beta for the simple equals some constant, okay? The true parameters beta 1 star, beta 2 star are below this, right? Because we know that when S is in power, if they could understand the true parameters, it means that they have lower intensity than the complex, so they are below the equal intensity curve, okay? So we know that beliefs have to satisfy equal intensity. We also know that beliefs have to be collinear with those of C, and in this case, collinear with the truth, okay? So here is the collinearity line of their beliefs. So beta 1 equals A, beta 1 star, beta 2 equals A, beta 2 star. This line must go through the true parameter value, and here is the equilibrium. So it's very easy to find out what are the equilibrium beliefs of group S. And again, the share of time that they have to be in power comes from the fact that we use the OLS equation for the belief. We can find their beliefs from this configuration, from these two equations already, collinearity and equal intensity, and then we impose that these beliefs satisfy the OLS condition given the share of time that S and C are in power, and we can find out this share of time and pinpoint this particular share gamma, okay? Okay, good. So let me spend a couple minutes about what's complicated here in terms of convergence. So there are several issues. For example, you can already see that there is an issue of misidentification, okay? So I'm correctly conjectured the average of what I'm producing, even if I'm by myself and I have the correct model, okay? So when we have more than one policy variable, there are many types of beliefs that could provide me with the same average output, okay? But even when you have we have a unique steady state, so this type of misidentification would yield many steady states, let's say just for the complex group. But even when we have a unique steady state, it's very difficult to ensure stability when we are in a multidimensional policy space and continuous action, okay? There is a recent paper by Sponda, Pozzo, and Yamamoto that shows it when they look at individuals with misspecified models, okay? The problem is that once you move away from a steady state, because you have endogenous actions and because you're learning given these endogenous actions and shocks that arise, it's not clear where your beliefs are going to go to and whether you can actually go back to the steady state. So we have a simple solution, not to dwell on this too much. What we do is add noise in policies. If you want to think about the application, you can think about bureaucratic type of noise. So essentially the output is a function of beta star and the policies plus some noise component. The components of the noise, again, IID with zero mean. And these are of course independent of both X and epsilon. Sometimes you can think about these environments, perhaps there was a question to that effect. You can think about politicians that experiment also, okay? Noise is also a way to capture some level of experimentation. Small scale of experimentation is almost analogous. It's not strategic experimentation, but it's a way to think about, small changes. This noise, for example, tells us that you would never you would never believe that a non-relevant policy is relevant. Okay, so in the more general model, when we add non-relevant policies, it's relatively easy to get rid of them. So one first thing that the noise is doing for us, after we prove a generalized law of large number theorem. Why generalized? Because of the non-IID feature of the data, right? When the data is IID, we all know they can use the law of large number, but there is a lot of recent literature looking at non-IID, and we do something similar, okay? Then with the noise and these law of large numbers, we can show that the beliefs of C converge to the truth, okay? So the fact that C has the correct model, and they're in power some of the times, and there is the noise there, then we can show that they converge to the truth. So we know where we want S to converge to, collinear multiplier of the beliefs of C. We can again use the noise and the law of large numbers to derive a deterministic law of motion for the belief of S, okay? Intuitively, okay, remember this was the equal intensity curve. If the beliefs of S are below the equal intensity, C is in power. When C, so I'm here, these are my beliefs. When C is in power, I'm getting more omitted variable bias. So I'm moving towards higher belief as we had before, okay? But the noise also takes me towards some truth, which is the collinearity line, the one that tells me what is the correct relationship between the different, correct relative importance between the different policy variables, okay? And when I move to the other side, so my beliefs are sufficiently high, then S is in power. So the beliefs of S are sufficiently high. They have less omitted variables. And again, the noise takes us towards the truth. They have the correct model, and the noise takes us towards the true parameter beta 1, beta 2, okay? So we have this long-term dynamics in which we know that you actually converge to the equilibrium that we've achieved, okay? Okay, so in terms of other questions that may arise, as I said, each group can also believe in many non-relevant policy tools. It could be that group S, which I call simple, maybe they start even with the largest set of policies that it believes to be relevant because it believes in 1,000 more non-relevant policies, okay? But we still maintain the assumption that group C considers all relevant policies and maybe others, and S only consider a subset of the relative policies, okay? So as long, relevant policies, so as long as S considers a subset of the relevant policies that C considers, okay? No matter how non-relevant policies both of them consider, in the steady state, they all learn about the non-relative policies. So hence, if you want, group S truly becomes a simple group, okay? I already said that the cycle result also applies to other formulations in which the two groups are overlapping, okay? So one group considers X1, 2, 3, the other 3, 4, and 5, okay? What our model doesn't have very good predictions about, or not very interesting predictions about, is the case in which you start from two completely non-overlapping groups, okay? So the last bullet point here. If one group thinks only about X1 and the other group thinks only about X2, then I cannot guarantee the cycle result. The cycle result relies on the fact that there is some overlap in our beliefs, and hence we both correctly conjecture the average of whatever the other group is producing. If we have completely non-overlapping policy variables, the fact that you implement X1 all the time doesn't change my beliefs about X2, okay? I don't consider X1, so I completely ignore what you do. So we're not necessarily going to have cycles. We can, depending on which parameters we start with, and of course the true parameters, we could keep one group in power indefinitely. It could be the wrong group. It could be the correct group. It's just there is not enough to, of course it's history dependent, but there is not enough to tie us down to an interesting type of result. Okay, so I think I'm finishing even 2 minutes earlier. Let me just conclude. We looked at the competition between a correctly specified and a misspecified model in politics. We combined it with a political competition model that relies on intensity of preferences. we looked at populism as, or at least we think, we use the simple group as an application to populism to highlight a few features of populism. First, the fact that it's simple, the fact that it keeps on coming up. So political cycles must arise in our analysis. The fact that the simplicity also implies extremism, which is another feature of populism. Okay, it doesn't always have to arise, but it arises in many cases. So in our model, the simplicity implies the colinearity of belief and hence extremism on all dimensions that you're looking at, okay? Extremism and the wrong policies, okay? And these are the key results. So I'm done and I'm happy to take questions. Thank you.
Thank you very much, Gilat, for being on time. We do have questions on chat, which Ronny suggested that people ask from you, or he answered them only partially. So I would go in the order these questions were raised. So the first we'll ask Michael Castanera to ask the question, then Francesca Trebbi, then QA Do, and then Tom Romer. Michael.
Hello, and thanks for a great presentation. I'm very impressed you managed to be even ahead of time. I never managed that. So actually, you answered my question. My question was about the case where you would have the true world is x1 plus x2, for instance. I believe in beta 0 plus x1. You believe in beta 0 plus x2, and we end up converging on, if you do well, it's because of beta 0, so we get neutral. And when I look at actual policies, it seems to be like this. With Republicans and Democrats these days, it's a bit like that. You believe in free trade, but no, I can do better by closing down the borders. And what bothers me more, I would say, is the fact that if you had the slightest doubt that the other model may be correct, you converge towards the usual Bayesian updating and correct conversions for everyone. So I remember a paper by Jean-Pierre Benoit and Juan Dubra that you don't seem to cite in the paper. The version I have, which is a temporary working paper, is called The Theory of Rational Attitude Polarization.
Okay, I don't know.
And so maybe that may be of interest.
Yeah, thank you.
But I loved it. Thanks.
Francesca, would you like to ask your question, or you're happy with Ronny's answer?
Hi, no, actually I didn't quite get it. So maybe, Gilat, thank you. Okay, could you just show us the model of learning through OLS? Because the way I'm thinking about it is you would do some hypothesis testing on your betas, not just look at the law of large number. You will have some sampling distribution around that, and I don't see how that's kind of.
No, it's true. It's just that the only thing that is important for your utility function in our model is the mean belief. Okay, so confidence interval is not going to matter. Okay.
But don't you want to reject some hypotheses about your betas?
No, you have your estimate. You simply compute your estimate around beta. Okay, x prime x over x prime y. Okay, and okay, so you simply compute your estimate. Okay, our model focuses on the fact that you have linear utility, so only mean beliefs are going to matter. If you think about the mean variance utility, for example, then we haven't completely checked it, but it's probably going to be the case that, because the C group has the correct model within the limit in the long term, they're going to be much more confident about their model. Okay, so if variance is going to be sufficiently important, risk aversion is going to be sufficiently important, we will probably lose the cycles result, and it could be that the complex will be in power.
Yeah, I think this is actually related to this small technical question I asked during the talk. If you have a model, which you have now, they only care about the mean. But if you have a model where you maximize mean y minus costs of x, since you have a square of x, you since you have nonlinear cost, you end up with risk aversion, and indeed you may
so
go into this mean variance.
We actually analyze in the paper a slightly more nuanced version when you care about Y plus V of R, which essentially present the opportunity cost from implementing. And then each group essentially also chooses different resource level, okay? So it's like we all agree on some dimensions, which are not in our model, or some policies, but these are the more policies that we have a conflict on. So having resources spent on them essentially takes away from other policies that we agree on, okay? And you know, we use second order approximation for quadratic form for this V of R, and then we have the same type of result. Yeah.
Excellent. So next question is from QA Do. QA.
Hi. So I wonder what happens with the opposite problem when actually C's model is also misspecified. I mean, so I understand if normally that would so coefficients that are 0 should converge to 0. But what happens? Well, a bit before the asymptotic results kick in. I mean, you know, before the long run. Say when C's model overfits the data, when you have too many parameters, and we could think that the long run, well, will eventually come, but may have to wait a very long time, given that the in this case the observations are not IID, and there could be a lot of you know, things could slow down a lot in the learning process. So I wonder in this case, C's policies can also be quite suboptimal, and so how, you know, what happens here?
Absolutely. So, you know, what we can say is about what happens in the long run. But in terms of the dynamics, our key results is the fact that we have cycles, right? Of course, also our result of colinearity is also a long run result, okay? But the cycle result is a dynamic type of result, okay? It cannot be that for too long, there is always some period after which we have to change power, okay? So in a sense, these are our results. And even if C considers some non-relevant parameters, this would be the case as well. So you're right that, again, we don't have to, maybe it was a populist thing to assume that C has the correct model. We're not married to that. The framework is more general, okay? And it could be that these are two groups, both of them have the wrong model. Okay, what we can say is that when one group has a subset of the relevant policies compared to the other group, okay, or when they're overlapping, we will always have cycles. And in the long term, we will also have the fact that the C group will know the true parameters and the S group will have a collinear beliefs and more exaggerated beliefs. So you're right. I don't know how long it will take until we reach the long term, and C could implement very, you know, quite wrong policies as well. Even when C is by itself without noise, I have misidentification. Even if they have the correct model, they can have very wrong policies, right?
Thanks, Tom Romer. Tom,
Thanks. Hi, Gilat. Hi, Ronny. Nice to see you, and it's terrific. I did have a question. What if we focused, or could you say something about the dynamics in Y, the outcome, rather than either the beliefs or the policies? And in particular, sort of on average, what, you know, as you have these alterations in power, what does the evolution of Y look like?
Right, so in the long term, the S group always gives us an inferior average Y, okay? Of course, there are the shocks.
Yes.
But, you know, take away the epsilons, which the epsilons have, of course, meaning towards in terms of changing in power. But in the long term, S produces an inferior Y compared to that of C.
Yes.
And they're always unpleasantly surprised when they see what they produce on average, okay? And pleasantly surprised when they see what the other group is producing. Okay?
Yes.
So this is the type of what we have in the long term.
Yes, and so what's missing from the model which is kind of what I thought intuitively.
Yeah.
What's missing from the model that doesn't allow a group from learning from the fact that they always do worse relative to the other group when they're in power?
They learn. I mean, they,
Yes.
always, all the time they learn. In the limit, they are converge very, very close to, all the time they concentrate on, in the limit, they concentrate on the beliefs that equalize intensity, but they hover around these beliefs, and the surprises, become smaller and smaller, but they are all the time surprised in some level, to some level.
Yes. And just as a final follow-up to this, a while ago, I was thinking of a model like this in terms of trust in government, and that basically we know that on average, there's been declines in trust in government. And in some sense, the wronger your model, the more you're likely to be unsatisfied with the outcomes you get from the government that you elect.
Yeah.
And so consistently, if you don't necessarily start believing that your model is wrong, you just think that the government is not trustworthy, right?
That's another way.
So this decline in trust in government is connected to the extent to which the outcomes you expected given your model aren't the ones that are realized. And so you say, well, it's because they didn't do the policies right or whatever. Right?
Absolutely. It's a nice way to interpret it. Right. Thank you. Yeah.
And that's exactly true, where indeed you as a populist voter think that you will benefit from replacing this government because you interpret the facts as this government being incompetent rather than unlucky.
Exactly.
Yeah, yeah, or corrupt. Yeah.
Or that the deep state undermined your government.
Exactly.
Right?
Exactly. Gilat, can I ask one question which I did ask on chat, but I think I wonder how do you interpret Simple's thinking about the complex? When Simple observes what complex does in power, Simple just believes that complex has a wrong model, is fully rational but wrong. Is that's the way you think about those guys?
Yeah, they see, they see them wasting resources on policies that, for example, I don't know, integration policies, right? They say, it's just no use. Maybe it's not going to hurt us. The policies themselves are not hurting. The resources spent are hurting us, but it's just not useful. And, why do they think that this is the right thing to go ahead? We should just build a wall. Yeah.
Right. So that is more like not corrupt, but stupid, right? So Simple thinks that complex is stupid.
Right, but I agree. We could interpret it in possibly another way. What we wanted to perhaps to say, we are stacking the cards most in favor of, to a degree of, no conflict in society, in the sense that I don't think the others are competent. I don't think they don't have different preferences. But you're right. I could think that they have different preferences. They really like integration per se, all these do-gooders, they just like other people and so on, okay? So that's the type of rhetoric that we have in the UK. So of course you can think that they have different preferences or they have different information, but we were just wanted to focus on the fact that, so it could be interpreted in this way, yeah.
But the model you have literally interprets different models, and the Simple just believes that the complex model is incorrect.
Yes.
And never does.
Yeah. I think we could incorporate other things as an interpretation, the way you described it. Yeah.
Okay, so we have time for one more question. Indeed, there is nothing wrong to finish early, but if there is a question, please go ahead and ask.
No, I don't finish early.
Yeah.
Okay. No questions? Okay, so let me thank Gilat and announce the next. Olga, you have a question. You need to unmute yourself. I see, Olga.
I don't have any question actually, so that's
Yelena has a question. Now, Yelena, you need to unmute yourself. You don't have a question.
It's not really a question, it's outside the model, but since stupid do not...
I call them simple, not stupid.
Simple.
I know, yes, it's not stupid and clever, it's simple and complex. So since stupid do not see all those other X's, they also do not see exogenous shocks that act as policies in the sense that they change outcomes predictably, systematically, you can observe. So could you possibly parameterize as a feasible case the entrenchment of stupid in office when they update as if from policies what is happening due to exogenous shocks. So in times of crisis, occasionally, if the gradient is correct, you get the escalating entrenchment of stupid. Just, as a feasible equilibrium.
So in our model, they do observe the output. So they observe what they think is beta prime x plus the shock epsilon, and everyone agrees on the distribution of epsilon. Otherwise, it's very difficult to compare their learning. And they could observe the policies of the others. It's just that they completely ignore them. This is a better interpretation from our point of view. But I think we can extend the model to think about the possibilities that there are some things that they don't observe and they interpret differently to a degree.
Okay,
this is what we're playing with. You can think that they don't observe X3 and that's how they interpret. Yeah.
Right, so there are shocks that last longer than the electoral cycle. So they are not really epsilon. They are something that Clever can incorporate into the model as a systematic effect and estimate with that in mind,
right.
But not stupid. And then the stupid will get carried away in the wrong direction.
Right, that's absolutely possible. Yeah, good, thank you.
Okay, thank you very much. As Mikhail correctly said, the presentation was very clear. And so that's why we are finishing on time, which is great. And before I let you all go, I would just say that the next seminar will be again the first Wednesday of November. And it will be Ekaterina Zhuravskaya who will speak with a paper which is not co-authored with me, for example. And then the December seminar will again be in the first Wednesday of the month. And it will be Maria Petrova who will speak. Maria is still with us, but she's muted. So thank you very much, Gilat. Let's run a round of applause and see each other in a month.